So for absolute value limits, we have to just write out the definition of what it means to be absolute value. So you have like an example here, like if we plug in 2, we get 2 minus 2 is 0, and that's already bad. So let's see the definition of absolute value. So if we have x, right, we're going to just say that it's equal to x, right? So you know how absolute value works, right? It's if the number inside is positive, then the when you evaluate the absolute value, the answer is also positive. But if the number inside is negative, like -4, the answer will just become the positive version of itself. So -4 becomes 4, right? And if it's 4, then it just stays 4. It's always just making it positive. So what we're gonna say here, it's just gonna state x if it's bigger than or equal to 0. And it's going to become negative x if it's less than or equal to 0. So if it's like negative something, right? Let's say it's -4, then we're going to multiply -4 by -1, that makes a 4. So this is like the definition of absolute value. And we're going to see why I wrote it down. Because now we have to evaluate this guy. If we plug in x minus 2 absolute value, when we write out the piecewise function, it's going to be like, you know, x minus 2 if, so it's going to stay the same if it's greater than or equal to 2. So why did I write 2? Because if we make it 2, if it's 1, for example, if it's 1, then this overall guy will be negative, right? And 1 minus 2 is -1. That's why it has to be 2 or bigger. X happens to be less than 2, right? That means that, let's say, what's this, the highest number that's less than 2? 1. If we plug in 1 here, what do we get? We're supposed to get -1, right? So that's why it has to be exactly, that's why it has to be exactly greater than or equal to 2. If it's 2, then it just becomes 0. So if it happens to be less than 2, which means it's going to be negative, like if we plug in 1 minus 2, this guy becomes -1. So if it happens to be -1 or less, then what we're going to do, we're just going to take the opposite of it. Take the opposite of -1, make it 1, like that. We're going to multiply it by -1. So now we've got our definition. Now what we're going to do is we're going to, as always, when direct substitution doesn't work, we're going to test for continuity. Just basically testing from the left and testing from the right. So limit as x approaches 2 from the left. Let's try the right first. Okay, so we're gonna plug it into our piecewise function that we got. We're gonna erase the definition. So let's plug it in from the right. If it's coming in from the right, let's recall how our graph will look like. This is like 2, and it's coming in from the right, 2.0001, and it's getting even. It's like 0, 1, 0, 1. Right? It's getting very close to 2, but it's always gonna be bigger than 2. So since it's coming in from right, it's always gonna be bigger than 2. We're just gonna say that that's equal to x minus 2. So when we plug in this guy, it's just x minus 2. No more absolute value because we've evaluated it. And then this guy becomes x minus 2. We just keep the denominator. And when we evaluate this guy, you see we can just cancel out the numerator denominator. And then they will just become 1. 1 over 1. And that's just 1. So the limit from the right is going to be 1. What about the limit from the left? We have to see if the limit from the right and the limit from the left are the same. So let's test the limit from the left. I'll write it here. Limit as x approaches 2 from the left. So again, just to refresh, from the left, you're coming in like 1.9999999999999. Okay, so that's what you're doing. And so if you're getting just below 2, you're going to use this one. So you're going to plug in that guy, x minus 2 over x minus 2. What do we see? We see, boom, they die. And where are we left with? We're left with that negative sign. So it's actually going to become -1 over 1. We know -1 over 1 is just -1. So you tell me, do the two limits match from the left and the right? Nope. We got -1 here and we got a 1 here. So what happens when the left limit and the right limit don't match? The limit does not exist. Just so that we fully understand this, so what we would write, we would write DNE does not exist.